Hi, Olivia here. Thanks for watching this video. We'll talk about code portability for IoT devices today, and we'll use Wilderness Labs Meadow for that, for demonstrating how you can port code from one IoT devices to another one in a seamless way thanks to Meadow, right? So I wrote an article about the topic, and I definitely invite you to go check it out. Description down there in the link down there in the description. In the meantime, let me get to it. So if you like this video, don't forget to subscribe to the channel. That always helps, and a little like is appreciated as well. So in order to demo the benefits of using .NET in that case for code portability for IoT devices, here's what I'm going to do. I'm going to try and develop an application that is about capturing temperature, humidity, and CO2 concentration information from a little sensor like this one, right? It's a I2 sensor, pretty straightforward. And for doing that, I'm going to have several steps in my development. The first one is going to be to use my desktop. Thanks to .NET, I can develop, because it's .NET, I can develop the application on my desktop. Could have been a Mac or a Linux device. I'm running Windows here, so I'll demo that on my Windows machine. The first step is going to be everything simulated. The display is simulated, the entire thing is simulated, and the sensor is simulated. The second step will be to connect a real device, a real sensor, sorry. The sensor will be connected through USB, through that I/O expander that will present itself as an I2C bus when I'm coding against it. Right? So it's going to be super interesting. I'll show you some about that. This is one of the features that is provided as part of the Meadow libraries. That's pretty cool. The second step is going to be to use an actual device. This guy here, the Project Lab from Wilderness Labs, again, that is a very great dev tool that will allow you to learn about Meadow and about embedded development using .NET. So for this one, I'm going to have a different platform than the previous one, but you'll see that I will try and reuse as much of the code as possible, the same code. And for that, you'll see how I'm going to leverage some of the constructs of .NET. This one has a similar display to the one I'll be simulating on my desktop. 320 by 240 in terms of resolution, and then the way I will interact with it, you'll see it's going to be the exact same way. I'm going to have a real sensor on that one, the same sensor actually directly connected to that device. My third part of the project will be to use a Raspberry Pi like this one, and to use a little two-line LCD display instead of the 320 by 240 OLED display. So that's going to be a different way of interacting with it, but I will try and make it as seamless for the application once again. So let's get to it. If you like this video, don't forget to subscribe to the channel. A little like is appreciated as well, and hope you'll come back for more. So let me get started here in my command prompt. What I'm going to do is I'm going to create a new application. A Meadow application. For that, I'm going to use some of the templates, but I need to eventually check which one I have installed. And one of the ones I'm going to be looking at will be the Meadow one. And here I need to create a Meadow desktop application. Okay. So let me create the project here. New. It's going to be Meadow desktop, and I will name that Windows Demo 2. And I will get in there and open VS Code. I already installed the SDK, the extension, everything. I discussed that in a previous video, so if you're interested, go check it out as well, where I do a Hello World with Wilderness Labs. So the way the application is constructed, is presented, is you have two main tasks in the application. One is initialize, the other one is run. In order to abstract the differences between different platforms, there's an interesting trick here, is that my main class, my application, inherits from the app base class and uses a template that corresponds to the type of device here, desktop. And you'll see later on when I'm doing the same thing with Project Lab, it's going to be a different template used in there, right? Let me zoom in a little so you see even better. So in this main file here, I can get rid of the chatter here. I don't need that right now. But because the application is inheriting from this base class with that template, now the meaning of the device object, device.display one actually, is different depending on which platform. Here on my desktop, device.display is a window on Windows. And I'm asking it to resize to 320 by 240. And you'll see using the Project Lab board, I will do the same exercise of doing a device.display, and you'll see how that works. But let's continue here. Then with that display that I just got from the platform, I will create what we call a display controller. In that template, you can see that anything that controls the display is in a separate file, separate class. And as in that display controller, what we do is we implement the function that are about initializing and eventually writing or creating content here. So this one is very simple. The only thing it does is in the constructor, it will create that display screen object, which is part of that Meadow Foundation graphics library that allows you to really rapidly build UI for embedded devices. And as you'll notice, independently of the hardware underneath of the display driver, I can just, in that case, create that display screen object, set a background, and then add controls. There's going to be one control added here, which is a label to display hello world. So once again, go read the documentation, go play around with all the samples. This is fascinating, but this definitely is a great tool for abstracting the way you interact with a type of hardware here. Let's run that application on my Windows machine. Let's create the configuration to launch the C# application on Windows so that it creates a window that is my display for this Meadow application. And here we go. The window has been created. You've seen how fast that was. We'll see with Project Lab how slower it is. Because it's an embedded device, you have more compile time and so on. But here I'm on desktop, I can be really fast in developing, and you'll see that. So hello world here is the only thing that the thing does, right? So I'm going to do more. So I was saying that what I want is to create an application that captures information like temperature, humidity, and so on, and displays that. So I prepared some code for that. I'm going to add code into my project that I pre-baked here. And you'll see that I'm going to use the exact same code and set of files in my different projects. The first thing I want to do is I want to create a type of display that is about displaying a temperature, a humidity, and a CO2 concentration information, right? I want to do that in a certain way when I have a display with multiple lines, and a different way with that shorter LCD display. But what I want is a base class for display controller that has a generic way of approaching this notion of temperature, humidity, and pressure. So I did add the file here, but I also need to add it into my project for it to be considered when I compile. So for that, I'm going to do to my CSproj file. I'm going to go here and add this little line here. And I'm going to just, oops, there you go. Item group, done. Okay, so now this file will be part of my projects. So what I can do, let me actually show you this base class first. So the base class here for the environment display is exposing some properties, temperature, humidity, and concentration. And then it has abstract methods that will be implemented in my code specific to the hardware to do a clear of the screen, to show the screen, to update it, as well as to draw text and draw a status. Status being a label plus a value. And there's that draw function is interesting because it's about putting everything together to have a display that will show temperature, humidity, concentration, and a title on top, right? So this one draw function is called each time the update function is called after the clear and before the show. Okay, so here is my base class. Here there's no notion of hardware. It's just a notion of a temperature, humidity, concentration that need to be drawn on the display. Okay, and because this is an abstract class and these are abstract methods, I will be able to implement the specific version for my Windows display, and then for the Project Lab display, and then for the Raspberry Pi display. So here we go, we have the basis here, which is this little guy. Now what I'm going to do here is add the using statement. So the namespace is environment display. Here I'm going to say that. Okay, and I'm going to have this one inherit from environment display base. And now suddenly VS Code just telling me there's a problem here because you have you're inheriting from an abstract class, and you need to implement the members that are abstract that have not been defined. So what I can do is actually, go there, use the quick fix, implement abstract class, which will generate the different prototypes for the methods here for me. So let me go down here. I don't need that in the constructor anymore. I don't want the display to show hello world, okay? The clear one will be a specific way of doing that. Right here, I'm using that display screen that's been created in the initializer. And here, what I will do is I will remove all the controls on my screen. That's the way that I'm clearing the screen. Now, if I want to draw the status, you remember the hello world, there was some way of adding a control, there was a label. What I'm going to do to make it faster is I'm going to grab code that I already wrote, so that way I will not do any typo, but you will see it's very similar to what was in that hello world code in that original constructor. So draw status is showing a label and then a value, right? So you can imagine text will be a label plus, the value, and that means that we'll have temperature and the value and humidity and the value, right? For each time the draw status function is called. The second one is going to be draw text, and that one I'm using it for drawing a title. And you can imagine more than just that, right? So here we go. We have a display controller that is prepared, is inheriting from that environment display base class. So it will display a temperature, humidity, and a concentration of CO2. So here I'm going to go back to my main application. For now, all good. I'm creating the display controller using that 320 by 240 this window. I'm just like, because this thing is nullable, I want to make sure that we don't have the warning here. No big deal. So now what I need to do is set some of the parameters for this. So display controller, remember, is now something that supports a property called temperature. And it's going to be in new meadow.units.temperature 25. I like that. Display controller relative humidity would be similar. And then display controller concentration will be similar. I don't know if 1000 is good. Let me put 600. Not sure if that's good or not. And I'm still in the constructing the initialization. What I want to do here, just test that my display controller is doing the right thing here. And well, my Copilot is really good here at inventing what next line of code I need to write. It's pretty comfortable. And one of the goodness of working with modern languages and tooling is that, as you can see, I just hit tab, 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 and the thing's just discovering for me what I need to write. That's fantastic. So here I have this little guy, because it's a simulated, environment display for a title looks good enough. I like it. Let me run that and see what happens. So let me do this, pointing to the right folder. So remember, I added that additional folder, created a workspace. Now I need to make sure I'm running the right code. And now it's starting, initializing, and not displaying what I want. Oh, because I'm missing something, right? I don't have my live coders with me. So I did set everything up, but I didn't call the update function. Update, there you go. Boom. That should work a bit better. Let's see. Once again, debugging and debug cycle, development cycle, good demo. It was not intentional, but it shows how easy and fast you can be on a desktop to do your app development. It would take more cycles and longer to do that on an actual device. So really comfortable and practical. Here we go. My environment display will show a title, temperature with a value, humidity with a value, and CO2 concentration with a value. Really neat. Now I need to see to have data from an actual sensor. Let's assume I don't have the sensor. Let's do that with a simulated device, simulated sensor. So the Meadow Foundation library contains a lot of interesting things for you that you will leverage, including many drivers for peripherals of different types and different sorts. And it includes simulated sensors as well, drivers for a simulated temperature sensor, a simulated humidity sensor. So similarly to my previous way of abstracting the environment display creating a new abstract class, I'll do the same for my environment sensor. So I have here this class, which is an abstract one called environment sensor base, and this one exposes temperature, humidity, and concentration, and an event handler pointer, so I can actually hook up a callback to that class. So when a temperature, humidity, or concentration change, I will be notified. So that base class you see doesn't do much. It just defines that we need to have, or we have these properties, and we need to have a callback. And then I created that simulated environment sensor class. And this one, what it does is inherits from that environment sensor base. So I don't need to rewrite that code. I can actually have that simulated sensor here, but then you'll see I can have a real sensor class as well using the same sensor base class. Temperature sensor. So we here have a simulated temperature sensor I was talking about, which is coming from that Meadow Foundation sensors library. This one will, as you'll see, just simulate a temperature sensor, the one for humidity as well. And there were none for the CO2 sensor. So I created my own simulated CO2 sensor down there. It's pretty straightforward. I copied the temperature one that's on GitHub and just changed things here and there. And now I have my CO2 simulated sensor. So when we initialize that class, we'll create these various objects, temperature sensor, humidity sensor, and concentration sensor, and we'll start the simulation. And then there's a timer that is set up when you call start updating, and timer will regularly trigger that callback that is attached on that event handler and notify was temperature, humidity, and concentration values, the latest that has been stored in my base class. Straightforward. Let's see how we can make that all work. So first thing, I did add a few sensors, so a few new libraries or classes. So I'm going to go to my XGS project, add the files so that they are part of my project, right? So here in my main application, I'm going to add this Olivier simulated environment sensor, because that's the one I need. I'm going to create here a environment sensor, or simulated environment sensor. It's going to be called environment sensor, like that. So don't need to be too specific. Okay. And I want it to be nullable eventually. And this little guy here, after the display has been updated, so here I don't need that, I don't want that actually. I'm going to create that new environment sensor, okay? And it will start updating. And here I need to indicate a time span, and that's going to be from seconds, and well, it's going to be a bit too fast. Let's do 3 seconds. All right, so my environment is ready to go. Now I will attach on my environment sensor, start updating. Oh, no, that's not the one. And that's the event, which is, where's my event? Sensor updated plus equals, and it tries to do something. So Copilot here tries to be smart and create that, display controller, clear, draw status. That's not bad, actually. That could have been what I wanted to do. But because I created a specific base class with that display controller to be a specific type of display controller, which is an environment one, what I'm going to do is instead I'm going to set the temperature to that new value. I'm going to do the same thing for humidity. So display controller, it's going to be relative humidity equals relative humidity. And then the last one is concentration, not bad. And then this time I will not forget, I will call the update function. Okay. Pretty straightforward. Created the simulated sensor, and just attach that callback. And now, because I receive temperature, humidity, and concentration information, each time I receive an update from the sensor, I will update the display, right? Once again, we are here on a 320 by 240 display. And let's do this and run the app. Let's see what happens. Perfect, it's going. Compiling. Okay, I have my window. And now each time I have a new update from the sensors, there you go, every 3 seconds, I'm going to have an update based on the simulation behavior. I know there's a little thing weird with that humidity simulated sensor. Don't have time to debug now, but I could do that here. directly in the comfort of my desktop application. Cool, right? So now I want to use an actual sensor. And for that, I'm going to use a really neat trick, which is leveraging that USB I/O expander. So this little device here, little card here, is very practical. It's connected over USB to my desktop and will present itself from the Meadow perspective as what we call an I/O expander. And I can use that to create an I2 bus and connect that real device to it. Okay? So let's do it. Once again, I was ready and I added that environment sensor.cs file. So this, remember the simulated environment sensor? It inherited from that environment sensor base, exposing temperature, humidity, and so on. But in that case, it was implementing a simulation. That other class here, the SCD40, which is the type of sensor I have here, right? This time I created that class that inherits from the same environment sensor base, which means my application will see it the same way, whether it's a simulated sensor or that's real hardware one. And in here, instead of creating simulators, I'm just leveraging this little guy here. So you see here, it's not resolving that class because I do have this using statement up here, but a couple of things I need to do. Well, first thing, I need to add the file in there. Where are you, man? The file. Okay. In my project. Sounds good. So that way I can have the right reference. And then what I will do, okay, so we're getting better here. So that sensor is almost there. Now what I need to do is adding the library that's missing. So let me actually go and search for it. Go here. And I will go to Wilderness Labs, and in here I will go to my developer documentation. I will go for the peripheral driver list, and in here I'm going to do that. That's going to be the fastest here. This little guy here is the environment sensor I'm using. I want this driver. I'm going to go fetch it, and I'm going to just go there, and that's what I'm going to grab. Perfect. I'm going to go back to my command line. I'm in the right folder here. I'm going to paste that, and I'm going to get the latest beta version. And there's a little trick here. I need to get the latest beta version because there's a little bug in the 1.11.0. So maybe by the time you watch the video, everything will be sorted out. So you might not need, you can just get the latest version here. So I'm installing that little guy here. Seems to be grabbing everything okay. Let's go back to my code. Things are fine. Whoa, I was able to resolve that. Perfect. I like it. Okay. So now what's going on in my application? What I can do is the following. Instead of using the simulated environment sensor, I'm going to use the one that is in here called the regular environment sensor, right? So that's what I'm gonna do. Okay, so sorry, that was this one. I'm gonna use this one now. Sorry, with the real sensor. So let me go here, do my using statement, using, or yeah, this one here. So I'm going to change that. It's no longer be a simulated one. It's going to be the SCD environment sensor, right? I'm not changing its name. I don't need to, but I'm changing the class name. Boom. And it's not a simulator, so I don't need to do that anymore. Perfect. And here, what I need though is an I2 bus object as a parameter, but I don't have one because on my device here, if I were calling that, I would actually get an exception because I don't have access, or not an exception actually, it would work, but I don't have any device like connected to it on my PC here. So what I need to do is create an I2 bus. For that, I'm using that trick of that IO expander. Okay, so for the IO expander, oh, actually a little typo here, correct? For the IO expander, what I have is an FT. Let me go back here. FT, what's number 232H? That's the expander. So I'm going to do that here. Let's go back one page. Okay, and FT 232H, that's the one. Let's go to it, and I'm gonna get this little guy here once again. Same exercise as before. Let me go in here, and let me install the better version as well. There you go. And to make sure there's no mismatch in terms of the versions here, what I'm gonna do is just put everything to beta. Things should work pretty well, but you are safer this way. You should not need to do that if you get to it, right? So now what I can do is create that expander object equals new. And what we do is ftdi, actually expander collection dot devices, and it's going to be this one here. Oh, my keyboard is going crazy. All right, that's better. And then, you know, what I can do is this, which is I squared to bus equals expander. Oh, actually, I'm really bad at typing today. Sorry for that. Create I squared to bus. Okay. So this guy here doesn't like that. My bad. And I'm creating the I squared to bus, and I'm passing it to this little object here, right? And then sensor updated, don't change the code. The display is not changed. It just replaced the type of sensor from a simulated one to a real one. And I'm just hooking things up here through that I squared to bus. Let's see. Things should be working. Let's see. Okay, all good. And now next time the sensor sends an update, I should get a new value up there. Boom, there we go. And these are real value from the real sensor here. Let me blow on it to spike the humidity a little bit. That's the easiest I found to check, you know, things there. There you see, my humidity is going up. Perfect. I'm actually using a real sensor. So, like, pretty straightforward. Creating an application. We're, what, 25 minutes in. Created an application from scratch, created a display that was about displaying specific information, created a simulated sensor, and then attached a real sensor to my desktop application. So now that I have done, you know, playing around with desktop, I need to play with an actual device. Okay, so what I will do is I'm going to bring up this other project, which is the, where are you? Project Lab project. This guy here. I'm gonna get rid of this and go here. Okay, so Meadow app, same kind of file, initialize, run, same functions. Difference here is that the template used for the app is F7 Core Compute V2. That's the hardware I'm using, and I'm gonna have it, you know, shown up there. Little guy. So let me use that. Oh, there you go. That's the guy here. Center that. For now, it's running the default application, default sample template. But what I want to do is show you how I can use an actual sensor as well and connect this thing. So I'm going to connect the real sensor to it. Boom, there you go. And if I look at the code, you'll see it's like pretty much the same thing. We're using the same common environment files here. The display controller is inheriting from that environment display base. In that case, you know, I'm initializing it using the micrographics library, which is the one that allows me to control this little guy here. And the draw text is just saying graphics, draw text. The draw status is 2 lines, draw text, right? So that way it's, you know, what I'm looking for. Yeah, so that's difference in implementation, but at the end of the day, my application here sees it as a display. It's a display controller created with that display here that is created from Project Lab.display. And, you know, that's pretty much it. Then I'm using the same SCD40 environment sensor as previously, but this time I'm creating the I squared 2 bus directly from my device object and not from the expander one, because I don't need an expander because I have that I squared C connector here. And then when the sensor is updated, I'm going to display temperature, humidity, concentration with that display controller that inherits from my class, the environment display one, right? All good. So same code basically was a tiny bit of change, but I can reuse most of my code actually that I've been testing on my desktop. So now let's see, it's connected on COM3. I'm going to run the little thing here and it's going to be deployed on this guy here. And we should see it running. Compilation went through, perfect. Will take longer, and actually that's a good way of demonstrating that, you know what, when you're developing with hardware, it takes longer. It takes longer each time you change a line of code to recompile and redeploy and rerun it. We get benefits from having cross debugging using that tethering over USB with Meadow and with the Project Lab. It's not always the case. Very often you can only use printfs and things like that to debug, and so you really need to use modern tools. That's a big advantage. Let's see what it says. Okay, device is configured. All cloud features are disabled. That's part of the settings of the app config. And there you go, it's running the application, it's been initialized. And now, boom, I'm receiving information when the sensor is updating, and I'm receiving concentration, temperature, relative humidity. There you go, perfect. Everything works. And I have a display that now is on an actual device that displays the same way as on my Windows application. Really practical. Last but not least, now we're going to change platform and change the display type. So now I'm going to switch this little guy here for this other little guy here. Let me put that aside. Oops, still in the field, doesn't matter. So Raspberry Pi, hats for connecting I2C devices. I'm going to use a simulated sensor. I could just grab this one and connect, but I'm missing a cable. There is an adapter from the Grove connector to the Quick connector, but that's fine. I'm just going to use this little guy here to display the same information. But as you can see, there's no way for me to display 4 lines of information here, and I don't even have the right length for that. Let me switch to my Raspberry Pi project. Where are you? Raspberry Pi project. So here, another aspect of development is really pleasant using modern tools. Once again, is I'm remotely connected to my Raspberry Pi, developing from Windows. I SSH into the device from within VS Code, and I can do cross debugging, sorry. So let me look at what's going on here. So a different display controller first, right? So this one inherits from the same display base. It has temperature, humidity, and concentration exposed, and update function. Pretty straightforward. But in here, here's what I'm doing differently. I'm creating a LCD object, which is coming from that Meadow Foundation Grove library. I will have all the drivers for Grove Connect, like sensors and displays and so on. And so in the constructor, I'm creating that display, which is well, actually I'm adding a title as well. Then I will use for the clear lines function, and then for the draw status, right line, and for the draw text, another right. Okay, so here I definitely can leverage the same code on my application to draw content on this display. A little trick here says each time I draw a line of text or a status on 2 lines, I do a little slip. So that way I can do a sequential drawing of the various information instead of having 3 of them. There's different ways of doing that. It could be scrolling, it could be whatever. Here, what I'm doing is pretty basic. Draw the 2 lines, wait a second, and then the next command will come in, draw the line, and sleep 1 second, okay? The application itself is the same. It's using the simulated environment sensor. So you're seeing the code here is exactly the same I was using on my Windows app. Here, initializing the object, starting the updating, done. And a little bit of difference here is for the LCD screen. I need the I2 bus, and this displays a new LCD object using the I2 bus, and I'm initializing my display controller, passing on that object, right? Which is pretty straightforward once again. So nothing really different from what you've seen before. Here I'm attaching the callback, and each time there's going to be an update on that simulated sensor, I'm going to display that information there on this device. Well, let's go and do it. Device not selected. Oh, because I didn't pick the right environment here. Let's do it. So everything goes well. On the device itself, I have Hello Grove that is displayed. And now I have temperature, humidity, and concentration coming from my simulated sensor that is displaying. Every 3 seconds, I have a new data coming in. It restarts the cycle of displaying all of that. The same code as you've seen, little modifications, but I was able to abstract the differences based on some of the construct, or thanks to some of the construct that our friend .NET is bringing, using abstract class and defining controllers and so on. So, you know, pretty portable in my own opinion. So I hope you enjoyed this video. Once again, don't forget to subscribe and check this little box for being notified when we publish new videos. See you soon.